allowing us to visualize the hundreds of billions of stars in our own Milky Way galaxy and the universe of galaxies beyond. But how could stars like these be responsible for everything we see around us? This is Whoopi Goldberg, and I'm here to join you on a journey to find out. Our first stop, a long, long time ago, over 13 billion years in the past, when there were no stars at all. There was only an invisible substance called dark matter, along with hydrogen and helium gas. Dark matter's gravity gathered this gas, forming the first stars. But these stars didn't last long. They were massive. They burned hot, lived fast, and died young. After they heated the gas nearby and ran out of fuel, they blew up in gigantic explosions called supernovas. Look, another one's forming. And there it goes. The first stars changed everything, combining hydrogen and helium into new elements, such as oxygen and carbon. Then supernovas blasted these elements into space, supplying ingredients for stars and planets to come. And though it may sound incredible, your body actually contains about a teaspoon's worth of this stuff, formed 13 billion years ago by the very first stars. Over the next few billion years, dark matter's gravity continued to draw gas together, forming new stars. Stars were born more rapidly at this time than at any other period in the history of the universe. And these stars cooked up more of the elements needed to produce the Earth and support life. This is when our home galaxy, the Milky Way, formed, devouring smaller galaxies of leftover gas to produce its majestic, whirling spiral. Something special happened in the Milky Way, in this dense cloud of gas and dust. Our sun was born. But not just the sun. Like most stars, the sun formed in a tightly packed group of stars called a cluster. The brightest young stars in the sun's cluster lit and heated this pocket within its birth cloud. If we speed up time, we can see the intense light of these bright stars driving the cloud away, revealing the stars within. Bright stars are bright because they're massive and hot. Mass is how much stuff there is in something. The brightest, most massive stars are blue. The least massive stars are red. Yellow stars like our sun are in between. Talk about star power. That star just exploded as a supernova. Only 1% of all stars do that. Stars and clusters orbit tightly around one another until they're ejected into space. But often, they don't leave alone. Many have one or more stellar companions. Many, like our sun, have planets of their own. And speaking of the sun, here it comes, along with the planets. We've seen the generations of stars that helped form those planets. Now, their future would depend upon energy from the sun. To find out how that energy is created, let's travel 4.5 billion years forward to the present day. There's no better way to understand how a star works than to look at one up close. And there's no better star to examine than our very own sun, the star that nurtures and supports life on Earth. Three satellites orbiting the sun not far from Earth took these images. They show the sun's outermost atmosphere called the corona. Its outer layers escape in a continuous solar wind. See those trails in orbit around the Earth? They show the paths of satellites. Some of them watch the sun. Others observe the weather or broadcast TV and GPS signals. These solar close-ups reveal a star that is more than just a big ball of gas. These glowing loops are solar storms. Beneath them, darker, cooler areas form, called sunspots. The sun generates the energy we feel when we step out of the shade on a sunny day. But how is this energy produced? Let's take a look. This flow, just below the sun's surface, is similar to the churning of water just before it boils. Go deeper, and we can see the swirling currents of gas that carry the sun's energy outward. This energy is generated deep in the center of the sun by one of the most powerful processes in the universe. Here, hydrogen atoms smash together, forming helium and releasing huge amounts of energy. This is called fusion, and it's why a star shines. The balance between the outward push of gas heated by fusion and the inward pull of gravity is what makes a star a star. But the sun, like many stars, makes more than light. The churning flow also generates vast magnetic fields shown by these swirling lines. Sunspots form when magnetic field lines get bunched together. Some sunspots are larger than Earth. The dynamic wind that blows away from the sun drags the magnetic field along with it at 1,000,000 miles an hour. You heard me, 1,000,000 miles an hour. Magnetic explosions on the sun can both drive strong blasts of this solar wind and produce dangerous radiation. blast from solar wind can interrupt TV signals and even cause blackouts. Fortunately, Earth's own magnetic field almost always protects us. Only a trickle of wind typically gets through, sliding down to the north and south poles. This causes radiant displays of light called auroras. We often think of space as empty, but the sun's influence reaches all the way out here and beyond. That's Saturn, another planet that has a magnetic field. Saturn has its own auroras. That line extending from Earth represents the path of Voyager 1, launched in 1977. In 2004, it discovered where the solar wind ends. Those are the greetings in 55 languages carried by Voyager on its journey to the stars. Just in case anyone's out there.
Hello from the children of planet Earth.
Voyager continues to travel across the region where the solar wind slams into the surrounding interstellar gas and the Milky Way's own magnetic field. The sun's power extends even beyond the solar system. But the sun won't always shine. What happens to most stars at the ends of their lives? $5 billion years from now, while the Milky Way is merging with its neighboring galaxy, Andromeda, the sun will become what is known as a red giant. Nearly all stars do that at the ends of their lives. Its outer layers will swell towards the Earth. Now don't worry, this will happen long after humans have moved on or evolved in ways we can only imagine. The sun's interior will also change. Incredibly, that bright yellow center will be larger than the sun is today. Finally, the sun, like most stars, will blow its ashes out into the galaxy, seeding new stars, new planets, and potentially new life. The remains of the sun's core, called a white dwarf, will take billions of years to cool and fade away. So, how do we know all of this? Around the world today, scientists observe stars and figure out what happened to them in the past and what will happen to them in the future. In the constellation Orion the Hunter, scientists have actually seen stars being born. And now you can too. This is the Orion Nebula. Those teardrop shapes are gas and dust clouds cradling infant stars. Huge stellar nurseries like this one are found all over the galaxy. There are disks whirling around some of these baby stars that may one day form new planets. Even now, star clusters are ejecting stars, just as the sun's cluster did over 4 billion years ago. Among them are the Pleiades. You may have seen the brightest of these stars, known as the Seven Sisters. Young stars are leaving this cluster at this very moment. And there are stars out there that are at the ends of their lives. The remains of one of these stars form this, the Helix Nebula. The star's core has already contracted into a dense white dwarf, so dense that a thimbleful would weigh as much as a full-grown hippopotamus. And matter from its ejected outer layers may someday form other stars and planets. Perhaps even planets like Earth. Or this matter might help form a kind of object scientists have only recently discovered. This is Gliese 229, a small red star not far from Earth. Orbiting this garden variety star is one of these strange objects. It's called a brown dwarf. Brown dwarfs are as numerous as stars, but they're not massive enough to fuse hydrogen like true stars do. The discovery of brown dwarfs tells us that our cosmic family is more diverse than we ever imagined. And who knows what will turn up next? But for now, we're going home. Pick a star, any star. Now, watch it closely. What color is it? Can you tell? Was it just born, or is it very old? After all, there are stars out there that are almost as old as the universe itself. We've learned a lot about stars and how they work, and yet they still seem so magical. So before the sun comes up, since you've already picked a star, why not make a wish? The light of the rising sun clearly reveals what stars have made possible. Everything we see around us was formed from elements made by stars. None of it would be here without the sheltering warmth of our own star, the sun. Our journey to the stars is truly a journey to the heart of what we are.